Picture this, a 1-ton robot dangling from cables, gently being lowered onto the surface of Mars.
Sounds like something out of a sci-fi movie.
It was a real nail-biter back in 2012 when Curiosity touched down using that crazy system, the Sky Crane. Years of work, all riding on this incredibly complex maneuver. And it worked. That daring landing, well, it was just the beginning of Curiosity's adventure.
It was the start of an epic journey to unlock the secrets of Gale Crater.
Welcome to Cosmos in a Pod Space and Astronomy series. This place, Gale Crater, it might have been a lot like Earth billions of years ago.
And that's why Curiosity is there. It's trying to figure out, could Mars have ever supported life? The information it sends back, it also helps us prepare for, well, for the day humans might set foot on Mars.
The discoveries are just extraordinary. Curiosity has changed how we think about Mars.
Oh, absolutely.
Before we get into those discoveries, could you give us a quick rundown on what makes Curiosity special? What kind of tech are we talking about?
Well, first off, it has a nuclear-powered heart, a radioisotope thermoelectric generator, an RTG for short. Basically, it uses the heat from decaying plutonium to create electricity.
So it's got a pretty long lifespan. Doesn't have to rely on the sun for power.
Exactly. It can operate for a surprisingly long time.
That's pretty crucial for a mission on Mars. What about the tools it uses to study Mars? What's in its scientific toolkit?
It's like a mobile laboratory jam-packed with all sorts of instruments. One of the coolest has got to be the ChemCam. It uses a laser, actually, to zap rocks, and then it analyzes what they're made of.
Wow, a laser-wielding geologist on Mars.
Pretty much. It studies the chemistry of Mars, all from a distance.
That is cool. Okay, so we've got a laser geologist. What other tools does it use?
Oh, there's SAM, the sample analysis at Mars. It sniffs out organic compounds, the building blocks of life. And then there's MAHLI, the Mars Hand Lens Imager. It takes close-up pictures of the Martian rocks and soil, like incredibly detailed pictures. We could never see this kind of detail from orbit.
It sounds like a real all-terrain science lab. But why Gale Crater? What makes it Curiosity's landing site?
Gale Crater is a massive impact crater. And right in the center, there's this peak called Mount Sharp. You can think of it like a giant layer cake of Martian history. Each layer represents a different era.
A time capsule, basically.
Exactly. By studying these layers, we can start to put together how the climate and environment on Mars changed over billions of years.
So it's like a time machine built into a mountain.
Right. Plus, there's evidence that Gale Crater once held liquid water, like ancient rivers, sedimentary deposits, that kind of thing.
Ah, liquid water. That's the key ingredient for life as we know it.
Exactly. So Gale Crater seems like the ideal place to search for, well, signs of past Martian life.
Okay. Gale Crater, a promising location. Curiosity, a rover with a laser-zapping geologist arm. That's a great start. Now, tell me, what exactly has Curiosity found in this ancient Martian lake bed?
One of the biggest findings has been the confirmation of ancient lakes. Curiosity found sedimentary rocks, especially ones that are rich in clay. And that indicates that there were, long-lasting freshwater lakes in Gale Crater billions of years ago. I mean, we're not talking about little puddles.
These were real, substantial bodies of water.
Yeah, they could have supported life, potentially.
Wow. Actual lakes on Mars. Just amazing to think about. That really changes our whole picture of what really Mars might have been like.
What other evidence has Curiosity found that points to this wetter past?
Well, it's found mineral veins, basically cracks that are filled with minerals, like gypsum, for example.
How did those form?
They form when water flows through cracks in the rock. It's another piece of the puzzle that suggests that, yeah, liquid water was once abundant on Mars.
Okay. So we've got ancient lake beds, we've got mineral veins, both pointing to a much wetter Martian past than we originally thought. But what about the big question? Any signs of life itself? That's where things get really interesting. Back in 2018, Curiosity made headlines when it detected organic molecules in Martian rocks. Carbon-based molecules, basically the essential building blocks of life.
Does that mean they found life on Mars?
Well, not necessarily. Organic molecules that can be created by processes that don't involve life at all. But the discovery means that Mars had the ingredients for life to emerge. That's a huge step forward.
So Mars had the potential for life. What about in the air? Has Curiosity discovered anything interesting in the Martian atmosphere?
It has, and this is something that's puzzled scientists for years.
Yeah.
Methane. Curiosity has measured these fluctuating levels of methane gas in the Martian atmosphere.
What's so special about methane? Why is that a big deal?
Well, methane is what we call a potential biosignature, meaning it could be a sign of biological activity.
Ah, I see.
You see, on Earth, most methane is produced by living things. So finding it on Mars, well, it raises some pretty interesting questions.
Is it possible Martian microbes are releasing this methane?
It's definitely one possibility, but it's not the only one. Methane can also be produced by geological processes. So the origin of this Martian methane is still a mystery. It's one of the most debated topics in Mars science.
Sounds like there's still a lot to learn. Curiosity is using some pretty high-tech methods to make these discoveries. Can you tell us a bit more about how it actually works?
Sure, one of its most important capabilities is its ability to drill and sample. It can actually drill into rocks, collect powdered samples, and then it analyzes those samples using its onboard instruments.
Like a miniature geologist with a jackhammer.
Right.
So what happens to the samples once they're collected?
They're analyzed by instruments like SAM, which we talked about earlier. SAM can identify the different molecules in the sample, including those organic compounds. It's a really powerful tool.
Incredible to think about this rover, millions of miles away, conducting these complex experiments. A real testament to, human ingenuity. Tell me more about these instruments. How do they actually work?
Well, take ChemCam, for instance. It doesn't even need to touch the rock. It uses a powerful laser to vaporize a tiny bit of the rock's surface. And then the light emitted by that vaporized material, that's what gets analyzed to figure out the chemical composition.
So they can figure out what a rock is made of without even touching it. What other techniques are used to study the landscape?
Well, Curiosity has several cameras, including high-resolution ones. These capture detailed images of the Martian terrain. And those images help scientists identify interesting features, understand the geology of the area, and, well, plan the rover's route.
Drilling, zapping rocks with lasers, taking pictures. Curiosity is a busy little bee. I imagine there have been some challenges along the way, though. Working on another planet can't be easy.
Oh, you're absolutely right. Mars is a really harsh environment. The rover has to deal with, extreme temperatures, dust storms, rough terrain. And then there's the fact that Mars is millions of miles away, so even sending a simple command, it takes a lot of time.
So operating the rover under those conditions must be incredibly challenging.
It is. One of the biggest challenges has been the wear and tear on Curiosity's wheels. I mean, they've taken a beating from the Martian terrain, and the team has had to get really creative to minimize damage.
I see. So even with all the careful planning, Mars can still throw you a curveball.
Absolutely. And then there's the whole issue of communication delays. Because of the vast distance between Earth and Mars, it can take up to 24 minutes for signals to travel between the two.
Wow. So the rover has to be pretty autonomous, right? It has to make some decisions on its own.
It does. But despite all these challenges, Curiosity has persevered. And it's given us so much knowledge about Mars.
Truly remarkable.
It's a success story. It's already exceeded its initial 2-year mission lifespan, and it's still going strong, making new discoveries all the time, a real testament to the team behind the mission.
It's a truly inspiring story.
It's amazing when you think about it, how much our perspective on Mars has changed because of Curiosity.
Yeah, it's true. Before Curiosity, Mars was just this distant, rusty red dot in the sky, And now we could almost picture ourselves standing there on the edge of Gale Crater, looking out at this landscape that was once shaped by flowing water.
It's pretty remarkable. Curiosity has really shown us that Mars is a far more dynamic and complex world than we ever imagined.
It's not just this static dead planet.
Right. It's a world with this rich geological history, It's a place where things happened, where change actually occurred over these vast stretches of time.
It really makes you think, if you had to choose, what would you say are the biggest takeaways from Curiosity's mission so far? What really changed the game for our understanding of Mars?
That's a good question. I think I'd say there are 3 major paradigm shifts.
Okay, let's hear them.
First, got confirmation of past liquid water on Mars. Before Curiosity, we had hints, We had these tantalizing clues. But Curiosity actually provided definitive proof that Mars was once a much warmer and wetter place.
A place that could support lakes and rivers.
Exactly, possibly for millions of years.
That is a fundamental shift in our understanding. Because liquid water, as we know it, is the essential ingredient for life.
Exactly. And that leads us to the second major shift, the discovery of organic molecules.
Yes, the building blocks of life.
This finding showed us that Mars had the basic building blocks necessary for life to emerge. It's like finding the ingredients for a cake in a long-abandoned kitchen.
Okay, I like that analogy.
It doesn't necessarily mean that someone actually baked a cake there, but it definitely opens up a possibility.
So we have evidence of a long-lasting watery environment and the building blocks of life. That's two strikes in favor of Mars's potential for habitability. What's the third big discovery that changed our view of the red planet?
The third big discovery is the realization that Mars has a much more dynamic and complex geological history than we initially thought.
So more than just ancient lakes.
Much more curiosity has revealed that Mars is not just this static, unchanging world. It's a planet that has been shaped by volcanic eruptions, impacts, and flowing water over billions of years.
It's a planet with a story to tell.
It really is.
Yeah.
And curiosity is helping us to read that story layer by layer.
Speaking of layers, Curiosity is still on the move exploring Gale Crater. It's currently on a mission to climb Mount Sharp, that massive central piece we talked about earlier. Can you tell us a bit more about that climb? What are scientists hoping to find as Curiosity ascends this Martian mountain?
Well, each layer of Mount Sharp represents a different chapter in Martian history.
Fascinating.
And by studying those layers, scientists are hoping to learn more about how Mars transitioned from a warmer, wetter world to the colder, drier planet we see today.
So Curiosity is essentially traveling through time, uncovering the secrets of Mars's past as it climbs higher and higher.
That's a great way to put it. One of the key questions scientists want to answer is how long those habitable conditions lasted on Mars.
For how long was Mars potentially suitable for life?
Exactly. By analyzing the rocks and minerals in each layer, they can determine when and for how long liquid water was present and what the climate was like during those periods.
So it's not just about finding evidence of past water. It's about understanding the duration and stability of those watery environments. Because the longer those conditions persisted, the greater the chances that life could have emerged and evolved.
Absolutely. And another question that scientists are hoping to address is the role of volcanic activity in Mars's past.
Oh, that's interesting. We know that Mars was once volcanically active.
Right.
Right. And Curiosity has found evidence of ancient volcanic eruptions in Gale Crater.
It has.
What kind of evidence?
Well, for example, it's discovered rocks that are chemically similar to those formed by volcanic eruptions here on Earth.
I see.
And these eruptions would have released gases into the atmosphere, potentially altering the climate and influencing the habitability of the planet.
So volcanoes could have played a role in both creating and destroying habitable environments on Mars.
That's right. It really highlights the complex interplay of factors that ultimately shape a planet's habitability. And it's something that Curiosity is helping us unravel piece by piece.
We've talked about ancient habitable environments and volcanoes. But there's another mystery that Curiosity is trying to solve. The mystery of the methane.
Ah, yes, the methane enigma.
You know, Curiosity detected those fluctuating levels of methane in the Martian atmosphere, and we still don't know for sure what's producing it.
Right.
Can you remind us why this methane is such a big deal?
Sure. Methane is considered a potential biosignature. Remember, it could be a sign of life on Earth. The vast majority of methane is produced by living organisms. So finding it on Mars naturally raises the question, could there be microbes living beneath the Martian surface, releasing methane as a byproduct of their metabolism?
That would be a groundbreaking discovery. Finding evidence of active microbial life on Mars would rewrite the textbooks.
It certainly would, but it's important to remember that there are also geological processes that can produce methane, Certain types of rocks can release methane when they interact with water.
So maybe there's water underground reacting with these rocks.
It's possible there could be underground reservoirs of water reacting with these rocks, releasing methane that slowly seeps up to the surface.
Okay, so we have two main suspects, geological processes and biological activity. How do scientists go about trying to determine which one is responsible for the methane on Mars?
That's the tricky part, It's a challenging task.
Well,
One approach is to study the isotopic composition of the methane. Different processes produce methane, with slightly different ratios of isotopes.
Isotopes. Different versions of the same element.
Right, and by analyzing these ratios, scientists can try to pinpoint the source of the methane.
It's like forensic science on a planetary scale.
It really is. And it's not just Curiosity that's on the case. The European Space Agency's Trace Gas Orbiter is also studying methane on Mars, and future missions will likely carry even more sophisticated instruments to help us unravel this enigma.
It sounds like this methane mystery will keep scientists busy for years to come.
Oh, absolutely. It's a puzzle that has captivated the imaginations of researchers around the world.
Trying to solve this Martian riddle.
And it's a testament to the power of scientific collaboration that we have multiple missions working together to solve it.
A global effort.
It's a reminder that science is a global endeavor, a shared pursuit of knowledge that transcends national boundaries.
We've talked about Curiosity's past accomplishments and its current mission, but I'm curious about its future. How much longer can this rover keep going? And what kind of legacy will it leave behind?
Well, Curiosity has already far exceeded its planned mission duration. It was originally designed for a 2-year mission, but it's been going strong for over a decade now, and it shows no signs of slowing down.
It's really
An
incredible.
amazing testament to the ingenuity of the engineers who built it.
Yeah, they did an amazing job.
The rover has endured these harsh conditions, mechanical challenges, software glitches, yet it continues to explore and send back valuable data.
It's a real survivor.
It is. But realistically, how much longer can it keep going? Well,
No.
there's no set expiration date.
Yeah.
You know, the limiting factors are likely to be the wear and tear on its wheels and the gradual degradation of its power source.
So eventually time will catch up with it.
Eventually, but as long as Curiosity remains operational, it will continue to explore and contribute to our understanding of Mars.
So it's like a marathon runner, pushing its limits and inspiring us with its resilience.
And its legacy will extend far beyond its eventual end of mission. Curiosity has paved the way for future missions, both robotic and human. Its discoveries have provided a foundation upon which other missions can build, and its data will continue to be analyzed by scientists for decades to come.
It's like a pioneer, charting a course for others to follow. And it's inspired a whole new generation of scientists and engineers who are dreaming of exploring Mars and beyond.
It's a true icon of space exploration, a symbol of human ingenuity and our insatiable thirst for knowledge. And as we look ahead to future missions, Curiosity's legacy will serve as a reminder of what we can achieve when we set our sights on the stars and dare to explore the unknown.
We're back and ready to tackle some even bigger questions about what it all means.
You know, the search for life beyond Earth, it's one of the most profound quests in all of science.
It really does. It makes you think about our place in the cosmos.
Yeah.
You know, before Curiosity, Mars just felt like this distant alien world.
Yeah.
But now, knowing it once had lakes and rivers,
Yeah.
maybe even the ingredients for life, it suddenly feels a lot closer to home.
Curiosity has shown us that the conditions for life as we know it, they're not unique to Earth. The building blocks are out there scattered throughout the universe.
And if they existed on Mars,
Why not on countless other planets and moons?
it's a mind-blowing thought. But if Mars was once so habitable, what happened? Why is it now this dry, dusty desert?
That's the big question, isn't it? It's a question that has puzzled scientists for decades. It seems that Mars underwent this dramatic transformation. At some point, it lost its magnetic field, and that allowed the solar wind to strip away its atmosphere. And without a thick atmosphere to protect it, the surface water just evaporated, and Mars became the world we see today.
So it's like this planetary tragedy.
Yeah.
You know, a once promising world,
Yeah.
potentially teeming with life. It's reduced to a barren wasteland.
It's a bit sad when you think about it, but there's still a glimmer of hope. Some scientists believe that life could still exist on Mars, perhaps in underground aquifers or other protected niches where liquid water might still linger.
So life could be hiding beneath the surface, waiting to be discovered.
It's possible. And that's one of the main goals of future missions. You know, they'll be equipped with instruments specifically designed to search for signs of past or present life, drilling deeper into the Martian crust, exploring those hidden pockets where life might still cling to existence.
It's so exciting to think that we might actually be on the verge of answering one of humanity's biggest questions. Are we alone in the universe?
It would be incredible. Even if we don't find evidence of life on Mars, the search itself is incredibly valuable. It pushes the boundaries of our technology, expands our knowledge of the universe, and forces us to confront our assumptions about the nature of life itself.
It's a journey of exploration, not just of Mars, but of ourselves.
That's a great way to put it. We're learning as much about humanity as we are about the red planet.
And that's what makes missions like Curiosity so inspiring. They're a testament to our curiosity, our ingenuity, and our relentless pursuit of knowledge.
I completely agree.
Curiosity has been exploring Mars for over a decade now, sending back all this incredible data that's transformed our understanding of this once familiar, now strange world. When you think about it, what do you think Curiosity's lasting legacy will be?
Well, Curiosity has fundamentally changed our view of Mars. It's shown us that the planet was once much more Earth-like than we ever imagined, with the potential for life. And it's paved the way for future missions, inspiring a new generation of scientists and engineers to explore the red planet and beyond.
It's amazing As we wrap up our deep dive into Curiosity's mission on Mars, I'm really struck by the profound implications of its discoveries. We've gone from seeing Mars as this cold, dead world to a place that might have once harbored life, a place
Yeah.
that still holds secrets waiting to be uncovered.
The mystery continues.
It does, and it makes you realize that this sense of wonder, this drive to explore, this is what makes us human. It's what compels us to reach for the stars, to seek out new worlds, to understand our place in this grand tapestry of the cosmos.
Beautifully said.
It's been an amazing journey. From those first grainy images of Gale Crater to the stunning panoramas Curiosity sends back today, this mission has truly captured our imagination and expanded our understanding of what's possible. And the story isn't over yet. Curiosity is still exploring, still making new discoveries, still inspiring us to dream big. If you've enjoyed this deep dive into Curiosity's mission on Mars, be sure to follow and subscribe to Cosmos in a Pod and our YouTube channel. For more explorations of the wonders of the universe, we'll be back next week with another cosmic adventure. Until then, keep looking up and keep exploring.